Welcome to Math Simplified by HM. I heartily welcome everyone to today's session on the Theorem of Geometric Mean. We are going to master the step-by-step geometric proof that connects a triangle's altitude to its hypotenuse. We are going to master the step-by-step geometric proof that connects a triangle's altitude to its hypotenuse segments. Please take a moment to like and share this video with your colleagues and friends, and be sure to subscribe and click the bell icon for more simplified math. Got your notebook ready? You can pause as we go. Let us get started. Theorem of Geometric Mean, a step-by-step geometric proof. The theorem: in a right angle triangle, the perpendicular segment to the hypotenuse from the opposite vertex is the geometric mean of the segments into which the hypotenuse is divided. Now we will break our given theorem statement in two parts: what is given and what we have to prove. Given: in right angle triangle PQR, angle PQR is 90 degree and segment QS is perpendicular to hypotenuse PR. What we have to prove? QS square is equal to PS into SR. Sec QS is the geometric mean of sec PS and segment SR. Construction: draw a perpendicular QS to hypotenuse SR such that S lies between P and R and they are collinear PSR. Now let us move to the first step, our proof. In triangle PQR, angle QPR plus angle PRQ plus angle PQR is equal to 180 degree, as sum of three angles of triangle is 180 degree, and we have angle PQR is equal to 90 degree. So we get angle QPR plus angle PRQ plus 90 is equal to 180 degree. Simplifying, we get angle QPR plus angle PRQ is equal to 90. Now in triangle QSR, angle SQR plus angle SRQ plus angle QSR 180 degree, and by our construction QSR is 90 degree, we get angle SQR plus angle SRQ plus 90 is equal to 180 degree. Therefore, simplifying, angle SQR plus angle SRQ is equal to 90. Therefore, from this we get angle QPR plus angle PRQ is equal to angle SQR plus angle SRQ. This gives us angle QPR is equal to angle SQR, say it is equal to X, since or because angle PRQ is equal to angle SRQ. Similarly, we can prove that angle QRP is equal to angle SQP, say that is equal to Y, and eventually it gives X plus Y is equal to 90 degree. Now in the right angle triangle PQR, we have drawn segment QS perpendicular to hypotenuse PR. Therefore, according to the property of similarity and right angled triangles, the two smaller triangles formed by the altitude are similar to each other. Therefore, triangle QSR is similar to triangle PSQ. Similarity of right triangles. Now, step 2 of proof. Since the two triangles are geometrically similar, that means triangle QSR is similar to triangle PSQ, the ratio of their corresponding sides must be equal. So setting up the proportion for the corresponding sides, we get QS upon PS is equal to SR upon SQ. QS upon PS is equal to SR upon SQ. Note that segment length SQ is the same as QS. So we can rewrite the equation as QS upon PS is equal to SR upon QS. From our proportional equations, by cross multiplying the terms, we multiply QS by QS and PS by SR. We get QS square is equal to PS into SR. Therefore, segment QS is the geometric mean of segment PS and segment SR, hence proved. Thank you all for your attention today. I will leave you with this. Just as similar triangles are zoomed in versions of each other, your small daily practice are just smaller versions of your future big success. Stay consistent. The ratio never lies. Please like and share this video with your well-wishers. Subscribe to the channel and click the bell icon to stay updated. Enjoy a great time and keep exploring the world of geometry.